Any thoughts? Might help if we sketch the picture. Again, this is outside of maybe the actual scope of the question, but let's say I have a graph. Let's say I have two y-intercepts when I'm dealing with a polynomial, which is supposed to be a function. Why is that bad? Or why am I not allowed to have that?
Well, for one, it wouldn't really pass the vertical line test.
Yeah, right? It's not a function anymore. I have one input, x is equal to 0, and I have two separate outputs, which is the top and the bottom, and so it would not be a function. I don't know if we specifically said the vertical line test, but the vertical line test is essentially checking exactly what I just said. Is there any input with two or more outputs? That's bad, and so that's why we will never have more than one y-intercept. Okay, that was a tangent. Now, we get to put all of the pieces together. Now I'm going to go through this process fairly slowly. It's definitely a weird process. It's good to practice this. But at any point, if you say, why did you do that in your brain, say that out loud. A lot of people are probably thinking the same thing. There's a lot of moving pieces. So for starters, the very first thing I found is actually the very first thing I'm going to use in my graph, my end behavior. Why am I using that first? Because it gives me my starting point and my ending point. So looking at my end behavior, on the right side of my graph goes to negative infinity. So this isn't very mathematical, but I know my graph's going to end somewhere over here. And this is going to the left. And as my values go to the left, my graph goes to positive infinity. So I know I'm going to start somewhere up here. Those are kind of placeholders. Those actually wouldn't appear on a real graph. Let me put in. As I kind of write in these axes, are there any questions about that starting thing? Great. Next step, plot all of my intercepts. 0, 2. What color do I want my graph? Red's always good. 0, 2 is right here. I have my x-intercept of -1 and an x-intercept of +1. Probably don't need to pause on that, but just in case, any questions about that? Cool. Now I play connect the dots. I start my pencil up here. Let's give it an arrow because that's going to go on forever and ever. We don't want to write it as a point. I'm going to start up here. I play connect the dots. I go to my very first point. And now I look at my 0. My 0 is -1. The multiplicity is 2. What does that mean for the point? Am I bouncing off of it? Am I crossing off of it? Am I wiggling on it? What do I do? Remember last time we kind of had that picture that showed us 3 possibilities based on the multiplicity.
Bouncing.
Bounce. Multiplicity 2 means I'm always going to bounce. So I go to that point, I bounce off of it, play connect the dots, I go to my next intercept. It's the y-intercept. I always cross the y-intercept. I can't bounce off of it because, again, that would break my definition of a function. So I'm going to cross it. Now I'm going to go to this next point. What do I do at that point? Do I bounce? Do I wiggle? Do I cross it? And it might help to look at the multiplicity of that intercept. Which is right here.
Would it be the wiggle?
Swoosh, whatever you want to call it. So I wiggle through this. It's going to look a little bit strange there, but honestly, that's good enough. Like I said, as long as you're not just doing a direct slash through that point, that's a pretty poor wiggle. If we're being honest, that would be good enough for me on an exam or anything like that. Cool. Now there are no more dots to connect. So I go to my point. It's worth mentioning, yes, this graph isn't 100% accurate. Your curve might look a little bit more steep here or something like that, or same over here. That's fine. We want to kind of just know what the general shape looks like. And the general shape would have a starting point of here on the left, ending point here, and would behave the same way that we did for all of those points. If we want to be extra careful, we can now erase those blue marks, and our graph goes on forever and ever in both directions. Everyone kind of good with that. We're going to practice it. Definitely lean on your other group mates when you're going through this. It's a pretty involved process. It's weird the first time you see it. Once you've done it 5, 6, 7, 8 times, it just becomes a game of connect the dots. Okay. One more example, I'll let you guys practice. As is the fun, wonderful theme of mathematics, we say, cool, you had an equation, you took all of that information and you made a graph. Now we have a graph, and I use Desmos, and Desmos doesn't always write arrows, so I'll just put in the arrows. You have a graph, and now I want you to be able to write an equation. So first thing, identify pieces of information. We don't have to go in any particular order. So does anyone have any observations about this graph?
The y-intercept being 0, -2?
Yep, that'd be helpful.
The x-intercepts are -1 and 2.
And so their zeros are exactly what you said. What are their multiplicities?
One and two.
Yep. It's 1 because we cross the graph here. It's a 2 because we bounce off the graph here. Perfect. Any other pieces of information we have? What about this stuff?
We got our domain, maybe?
We do have our domain. It's -infinity to infinity. What else do we have with those arrows?
As x approaches infinity, f of x goes -infinity.
Yep.
As x approaches -infinity, f of x approaches +infinity.
Great. So that's my end behavior. What does that tell me about the degree? What does that tell me about the leading coefficient? This is where it might be helpful to have that chart. We're going backwards now. So, and when we were doing the information about the graph or the equation, we wanted to use that to find our end behavior. Now we want to have our end behavior to find our degree and our leading coefficient. guess the sign of our leading coefficient. As an aside, while people are thinking, let's just go ahead and write the end behavior. So back with 0. That's something that we can look at the chart that I've displayed and we can say, boom, this falls into the category that gives us a degree. It doesn't actually give us the actual degree, but it says it's odd or even. And it also tells us what my K should be. Positive or negative.
So the degree will be odd and K will be less than 0.
Yep. Okay. Yeah, so Jackie asked, how do you find the degree in the K? If you have the chart and you know what the end behavior is, you can look at each of the 4 squares, and only one of those squares will have this end behavior, specifically the square that has an odd degree and K less than 1. So that's how you figure it out. That's a good question. Okay, we're writing the equation. It's a function, so let's start with f of x. I'm going to put a blank here because I need to fill in that information. We'll talk about that shortly. And I'm going to have 2 factors. What are those 2 factors going to be? We did something like this before last class period. We took information about my zeros and their multiplicity, and I wrote an equation. That's where we're at right now. I know my zeros, I know their multiplicity, and I know my y-intercept. I should be able to write an equation in the exact same way I did that problem.
Would it be
X
x
plus
plus
1.
2 and x minus 1 in the parentheses?
Close. You have to flip your sign. So it's x plus 1, x minus 2. So maybe here we do before we put those in our functions. Yeah. Okay.
And that
are there powers?
X minus 2 will be squared. X plus 1 is just going to be
So my multiplicity
the first degree.
is 1. If we want to write that, we don't have to. My multiplicity of x minus 2, or the 0 associated with that, is squared. Okay. Now what do I do? Like I said, we've seen this equation at this point, or this problem process. Has to do with this blank. I don't know what's here, so we put a placeholder.
You need to find A.
Yeah, how do I do that?
Do we fill in X and Y?
Yep. So I know my y-intercept is 0, -2. So my y is -2. I'm trying to find my A, plug in 0 for my axis. James is the king of plugging stuff in. Okay.
Thank you.
Yeah, absolutely. 0 plus 1 is 1, so that's just going to be 1. Might as well write it. 0 minus 2 is -2. Squared gets me +4. -2 is equal to 4a. Running out of space. My a, once I reduce it, always reduce your fractions, is -1/2. So the question's asking for an equation. Make sure you don't stop there and say, oh, I found everything. I found my a, I found my factors. Make sure you write a final function. So that's my final answer. Now, if we're being honest, I didn't use this piece of information when I was building my equation. So that process was a little bit weird of, okay, now I have to find my behavior, and now I have to match it with the chart and figure out my degree and my leading coefficient. If you're getting lost there, you don't have to do it. I very much recommend doing it because now that I have my answer, I can do a quick check. Okay, my degree is 1 + 2 is 3, so cool, that's great. My leading coefficient is negative, great. We have that little bit of extra check, the little bit of insurance. We don't really need that. We can build this equation entirely off of this information. So there was a question of how do we find these exponents right here and right here. Those exponents are going to be the multiplicity of my zeros, multiplicity 1, multiplicity 2. And then also maybe worth mentioning that this matches up with the 0 here. This matches up with the 0 here. So that's how you know which one goes where. Any questions?
I have a question about finding the multiplicities. So how do we look at the graph to interpret like if it's going to bounce or like wiggle off of those points, our intercepts?
I mean, the bounces should be pretty straightforward. A bounce is always going to, if I have an intercept here and it's going to bounce, my graph should always fully change direction. That's always going to be what a bounce looks like. Fair question about a swoosh, especially if I were to like kind of draw a graph by hand and look or show it to you and say, is this a swoosh or is this a cross? If it is a question on the exam, the swoosh will be very exaggerated. So if it's on the exam, the swoosh will be like almost impossible to miss as opposed to a cross. Does that help?
Yeah, so on the left, since it goes through that point, that's a cross. And so that's what makes it a 1.
Yep. Yeah, actually, this is kind of nice as an example. This is my cross, this is my swoosh, this is my bounce. That's what they should look like. Also, that would be a great question on the exam to just ask me, be like, is this a swoosh or is this a cross? Because I mean, I could tell you which is that, and it's not going to really help you solve the entire equation. It's just going to help you clarify what the drawing's asking for. So definitely ask if you're unsure. Good questions. A lot of good questions. Hopefully you'll ask a lot of good questions in your group as well. Any other questions?
I don't know if you caught it, but I think someone asked a question in the chat.
Yeah, I caught it. They're asking about the degree and coefficient, and then they're asking about the exponents. So hopefully I answered that. So this is going to feel completely different from what we did in the first 2 sections. The first section we were talking about and behavior and multiplicities, and then we moved into this section with being able to graph. And so what we're doing in this section is something called synthetic division. And the process has almost nothing to do with graphing in itself, but there is a relation between the two. Specifically, what the advantage of doing what we're about to do is sometimes we have equations that aren't in this nice form. Like if this was something, x to the 7th plus 3x squared plus 20, something like that. I don't know a lot of information about the graph. I don't know my zeros. I don't know their multiplicities. And so what synthetic division allows us to do is it allows us to take something like this and ideally get it into this form. So that's the loose connection between the two. I don't think there's ever a question asking you to do both because they're both kind of involved processes, but they are related. I just, as a kind of preparation or a motivation to where this comes from. Okay, and so the first thing we talk about is the remainder theorem. And in the book, they write out the remainder theorem very formally. It is a very powerful theorem in mathematics. We're not going to really state it very formally. We're just going to talk about how it's used. And how the remainder theorem works is it says, okay, if this is a factor, so if x minus 2 is a factor of x cubed minus 4x plus 6, if this can be written something like this, it's one of the pieces of the zeros, then the zero associated with it, so the zero associated with x minus 2. If we take that and plug it into our function, it will be equal to 0. So in this case, the 0 is what? Associated with x minus 2. Or the x-intercept associated with it, whatever helps you.
2.
Yeah, positive 2. And so the question becomes, is f of 2 equal to 0? If the answer is yes, it's a factor. The answer is no, it's not a factor. I can't pull that out and start to make it in the nice form, or at least this factor itself is not going to be part of the nice form. And so while that's just an evaluation question, that's something we've seen before. So I plug in my 2. My 2 cubed is 8. 4 minus 2 is negative 8. That's 6. So positive 6. That's not 0. So it is not a factor. There will be a question on the exam. It is one of the most frequently missed questions because we just cover it so briefly and people think, oh, I don't really need to know that. It's a weird theorem. You need to know this. There will be a question on the exam almost exactly of this flavor. I'll give you a polynomial. I'll give you a factor. You have to tell me, is it a factor? Why or why not? Everyone good with that? Cool. Again, this probably shows up on the worksheet in my math lab. It won't show up on the exam. I'll probably talk about it after the exam because it is kind of cool, but it gets lost in translation if I bring it up right now. But this we can do and should do. So stop video because I'm going to want to draw. Now in this video, I believe someone should correct me if I'm wrong, or if you haven't seen it, that's fine. In 5.3, I show 2 ways to do division. I say, okay, we have polynomial long division, we have synthetic division. The polynomial long division is very involved. There's a lot of steps. It's easy to mix up a sign. It's hard to get the correct answer consistently. The nice thing about that is it always works. And so if you are planning on going to higher level mathematics, yeah, we sometimes kind of talk about polynomial long division. And usually I take the, oh, blanket, this works for everything, so we should learn that and that's more important, versus this is very specialized and easier. This is kind of the exception to the rule. This is so much easier than polynomial long division, and it does have so many applications. Sure, it's slightly limited. They have so many applications that I prefer synthetic division over polynomial long division. If you like both, or if you like long division more than synthetic, you can use polynomial long division. I know how that works. I talked about it in the video. If you put that on the exam, I'll track it and you'll be good to go. I recommend synthetic division. It's a little bit easier to track. That being said, synthetic division, the first time you see it is kind of weird. Once you do it 2 or 3 times, it's a fairly simple process, but first time feels weird. Okay. First step is take this, determine the 0 associated with it. What's the 0 associated with x plus 2?
-2.
-2. Just flip the sign. Okay. So my first step in synthetic division is make a little box, put -2 there. Just this guy. Next step, I translate these into numbers. And so I have x to the 4th, 2x squared minus x plus 5. And so the coefficient associated with the x to the 4th is just 1. So I put a 1 here. The coefficient associated with x cubed Now I always want to go in descending order. I always want to go 4, 3, 2, 1 constant, or 5, 4, 2, 3, 1 constant. So what is the coefficient associated with x cubed here? It's a little bit of a trick question.
Would it be 0?
Yeah, there isn't an x cubed, so you need to put in that placeholder of 0. So we can maybe make a note to the side. That's worse. One more try. There we go. If we're not missing anything, if this was nice and went x to the 4, 3x cubed down in the order, we don't have to put that 0 filler, but be aware that sometimes we have to fill in that spot with a 0. Now my x squared term is 2, the coefficient in front of x squared. The coefficient in front of x is -1, and my constant term is 5. Everyone good with that part of the process? Okay, now we start the actual process. Some people put a dotted line here. I'm good either way. I guess I'll put it in here, but you don't really need that necessarily if you're able to track what's going on. First step, drop 1, do nothing with it. Step 2, I take my -1, I multiply it by the thing in the box. So that gets me -2. I put that here. And then I add. And that's the process. The first step, we always drop something down. After that, we do this cycle of multiply by the thing in the box, put that thing below the next term, add. Multiply by the thing in the box, -2 times -2 is 4. Put it there, add 6. Multiply by the thing in the box. Multiply by the thing in the box times -2. It's -12, add. Multiply by the thing in the box, gets me -26, +26, add. Everyone good with that? Okay, well, now I just have numbers floating out there. Oh, sorry, the chat, and I didn't open it up. Let's see. Okay. Yeah, so now I just have weird numbers floating there. Nothing's like really back in the polynomial form. I should probably have x's flying around somewhere. And so my last step is to translate this. And so I translate that by starting with this. It's 4. I do my power. My new power is going to be whatever it was before, 4 minus 1. So my new power is going to be, I start with x cubed. It was originally x to the 4th. Now I'm going to start with x cubed. So when I translate this back, I say, okay, my first term is going to be 1 x cubed. My next term is going to be -2 x squared. My next term is going to be +6 x. My last term is -13. All I did was start with my x cubed and then I counted down. 3, 2, 1, constant. Okay. Now, the reason why some people put a dotted line here is it helps me separate and say, this is actually my remainder here. So that's why that's there, is people like to say, oh, that's not really part of my answer. I mean, it kind of is, but that's my remainder. So that helps me determine if this is a factor or it's not. So is x plus 2 a factor of my polynomial? It's just a question kind of from the last slide. Write down what I'm saying. Saying x minus 2. Is x plus 2 a factor?
No, it's not.
Yeah. Why not?
Because there's a remainder.
Remainder is not 0. Exactly. Yeah. Now, if I want to be fancy, and this is kind of going back to maybe what we did with long division. The first time where people learn long division, you go through this process of dividing all of your pieces, and this is long division. It's just kind of disguised in this weird form. This is long division. We get to a remainder. And then when you get kind of better at it, you say, okay, I don't really want a remainder. I want to keep getting additional decimals, blah, 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 whatever. But we're going to actually stop at the first part with the remainder. The only thing we have to do now is we say, okay, that's my remainder, 31. And my factor doesn't fit into it. If it did, my remainder would be 0. So since it doesn't, I just say, I have this leftover thing. If I could divide it, I would. I can't, so I'm going to stop. So we have 5 minutes in class, 2 options. If everyone's brain is broken, we can call it a day. You guys can watch the video, review over the weekend, make sure you feel comfortable with it. I can also do another example if you guys want to. I was going to give you guys a chance to practice it, but 5 minutes isn't very long. So I probably won't have you submit this worksheet.
Yeah, can you just do one more example?
Yeah, okay. I mean, obviously, if you don't want me to do another example, you can go ahead and head out and submit what you have. But yeah, I think another example is going to be good. So I'll clear this. Let's just make a random problem. Where's delete? Okay, it'll work. Okay. Random one. So I don't know. X to the third minus 2x squared plus 4x minus 6. And let's say we're dividing that by x plus 2. Let's do x minus 3. First step, I determine the 0. What is the 0 of this?
3.
Yeah. Next step, box that 3. Okay, what do I do after that?
That's when we translate it into numbers.
Yeah, right. So I have my 1 in front of my x cubed. I have that invisible 1. I have my -2. I have my 4. I have my 6. Notice how in this case, I don't have any missing terms, right? I have 3, 2, 1 constant. I'm not missing an x cubed like I was last time. I'm not missing an x or anything. So we don't actually need any of those filler zeros. So I do 1, -2, 4, -6. Everyone good with that? Okay. I'll put this down here. I'm gonna put this, again, that dashed line is, some people love it, some people don't. So if you're looking online at other resources and they don't put the dashed line, it's not really a big deal. I don't really need it if you're tracking with the actual process. Okay, what do I do now?
This is where you drop it down and then you multiply and then add, right?
Yep, very first step, always drop down the first term, do nothing with that. Next step, multiply the 1 by the 3, which is 3, put that 3 right here. Plus -2 is 1, just adding the 2, which kind of makes sense. It looks like an addition problem if we were to set it up kind of back when we learned vertical addition the first time. And then repeat. 1 times 3 gets me 3 again. 3 plus 4 gets me 7. 7 times 3 gets me 21. -6 plus 21 is 15. Is this a factor?
No,
Why not?
because x doesn't equal 15. Well, -3 doesn't equal 15.
No, 15 is not 0, my remainder. That's how you determine as you look at the remainder. And I know the 2 examples we see in the remainder hasn't been, or I guess the 3, the remainder hasn't been 0. That's not always the case. It's just kind of hard to design a problem like that on the fly. So you do see questions that have a remainder of 0. In fact, that's kind of the nicer case. That's the goal. We want to find stuff that does do that. Okay. Now what do I do?
You subtract 1, so now it'd be x squared.
Yeah, so I'm going to start with x squared. It's 1 less power than what I started with. And so it's 1x squared plus, I go in descending order, 1x plus 7. And then my remainder is 15, so I do plus 15 divided by my original thing I was dividing by. You're learning a new skill. Learning a new skill is always super hard when you start it. This, fortunately, is a skill that once you have practice, it almost becomes automatic. It's the process itself is you're doing multiplication and addition a couple of times. It's just you haven't seen it before, or most of you haven't seen it before.
Wait, so why do we put the x minus 3 underneath the 15?
Yeah, so my remainder is 15. So what that tells me is that when I go through and divide this thing, when I divide my x minus 3, I have this leftover 15. It doesn't fit in nicely. And so essentially what I'm doing when I'm saying 15 over x minus 3 is I'm giving up. I say, okay, I know what the first thing is, the second thing is, the third thing is, and then I have this weird 15 lingering there. Well, I started by dividing by x minus 3, and I say, okay, if I could, I would like to find this. I don't really know what that is, so I'm stuck.
Oh, okay, that makes sense.
Yep, no, that's a very good question.
Quick question. Say if the remainder does end up being 0.
Yep.
You end the equation with like a plus 0, or can it just be blank?
Yeah, so let's say that this was the remainder of 0. Then my final answer would just be blank. I would just be left with x squared plus x plus 7. If you wanted to write a 0, that's fine, but that's the same thing. Writing a 0 and leaving it out is the same.
All right, thanks.
Yeah, good question. Hopefully you guys feel a little bit better about this.
Yeah, that second example really helped.
Cool. I'm glad. So yeah, classes done for sure. I'm posting the lecture video from last class period as we speak. I'll post this one, I don't know, probably in an hour or so whenever it's done doing its thing.